Hello and welcome to Okube, an organization building open source solutions for data intelligence. Today we go over Laktory Data Source models which simplify reading files, tables, or streams in the context of a pipeline or any Spark-based job. As with any other Laktory model, they can be instantiated from a configuration file or directly in a Python script. Let's explore how to use them and what kind of features they have to offer. But before we do, if you want to ramp up your data and AI engineering game, make sure to like and subscribe. To understand how data source models work, we start with an empty generic notebook. The only requirement is that Laktory has been installed, which you can do by adding the library to the selected cluster, or install specifically for the notebook using pip install command. The first cell simply import models module and settings from Laktory. In this first example, we will create an events data source, meaning that we are about to read a collection of event files, typically generated by a data producer and stored as JSON or CSV on a cloud storage. In this case, we are interested in reading stock prices from Yahoo Finance. As you can see, deciding to read the data as a stream or as a complete data set as simple as setting read as stream to true or false. Let's explore the source object to see how. The expected location of these events is automatically defined. The event's root is the expected location for all events. If you are on Databricks, it is generally recommended to use volumes to make your data available. If you need guidance on using volumes, check out the demo in description below. The event root, on the other hand, is the location of the specific event we want to read. It is essentially a combination of the event's root, the producer name, and the event name. Listing the files in this root directory shows that the data is organized by year. Let's have a look at one of these events. As you can see, it's a simple JSON file with nested structures storing price information. There is one file per stock per day. Coming back to our notebook, let's use the data source read method to explore the resulting data frame. As expected, the schema is aligned with the content of the JSON files. There is a data column with nested stock price properties, and other columns like name and producer. Now let's build a streaming data frame by simply setting the set as stream option to true. We also introduce some of the data source properties for post-processing the data frame. The filter option applies a filter based on the provided SQL statement. The selects options defines which columns are selected and to what they are renamed. Again, we use the read method to read the dataset and print the schema to validate that our processing has been applied. We can also check the isStreaming property to validate that we generated a streaming data frame. This is all very nice. But what if the location of the events is not the default location assumed by Laktory? No worries. You can directly input the event root in the definition of the source. Here is an example with a custom location. On top of that, you can also customize the Laktory default location for all events, which is stored in the workspace landing root settings. To change the default value, simply make sure to update Laktory workspace landing root environment variable with the custom path. Now let's explore the table data source. In this case, instead of loading a collection of isolated events, we load a data table or Spark data frame to define the table you want to read. Provide its name, schema, and catalog. For table sources, you also need to specify if the table is read from a pipeline or not. This is used for sequencing updates when a table source is used in the context of a data pipeline. If you simply read a table without being in a pipeline and without using stream, the read method will simply call spark.read.table command. So here we have the resulting data frame, which is an exact representation of the target table. As with events data sources, we can use the read as stream options to create a streaming data frame from the table, assuming it's a delta table. Finally, if the data table is not registered in a catalog, but is available from a disk location, we can directly input the relevant path. If you provide both the table name and a path, an error will be raised. Now you know how to use event and table data sources to read data in an isolated notebook. However, the real value of the data source models is to use them in the context of a data pipeline. Let's look at an example where we define a bronze and a silver table. The first thing you might notice is that we import DLT from Laktory, enabling us to use additional debugging features. For the bronze table, we have an event data source very similar to what we have seen so far. There is no additional transformation to the data. For the silver table, we have a table data source that references the bronze table we declared above. Notice that we now have to set from pipeline to true to resolve the dependency between the two tables. In this case, we also added some data transformations to the output of the reader. Let's have a look at the DLT pipeline to see what kind of output we have. As expected, we have two tables. The bronze table has the raw events schema, while the downstream silver table has the new schema resulting from the data transformation. What is so special about the data source models is that they can be used for both pipeline and isolated runs. As we have shown, the readers worked as normal DLT read command, but they also allow to debug the pipeline when running the notebook against a normal cluster. As we can see, running the first cell generate the same data frame as the pipeline would. The same story goes for the silver table. You can run the cell and preview the result of the silver table. This would never be possible with the normal DLT read command. The reason why Laktory allows this seamless transition is because it is highly context aware. When ran from a pipeline, the read method uses DLT read and read stream. Otherwise, it fallbacks on spark.read.table. The notebooks showed how to configure a data source programmatically. However, when fully leveraging Laktory stacks, these sources would be set up in the configuration file of the pipeline. For example, in this YAML file, we define a source for our bronze and silver tables. This concludes our tutorial on Laktory Data Sources. Today we have learned how to create events and table sources and how to use them to read data as batch or as stream. The highly configurable data source model also allows data transformations like filtering and column selection. Finally, we show that the main benefit of these data sources is that they can be used both in the context of a pipeline or a standalone notebook and will still yield an output data frame. We hope it was helpful. What kind of data sources would you like to be supported next? Maybe Kafka or other streaming services? Let us know in the comments below, and see you next time!